Welcome to Automate and Learn with Yogesh. Today we will learn about Amazon S3 performance. So we have S3, which is designed for massive scaling plus high throughput, and you can still use some rules which is known for performance. First of all, we can go with request rate and throughput. With Amazon S3 bucket, you get virtually unlimited scaling, but prefix you can achieve roughly around 3500 put, copy, post, and delete requests per seconds, as well as you can get around 5500 get requests per second, and you can scale horizontally, that is multiple prefixes is equal to highly throughput. Example is given over here. Next we have prefix optimization. It's for old rule, what happened now, it have random prefix required. So as per new S3 policies, S3 optimization, S3 has auto scalings internally. So it's still useful for extremely high workloads as well as parallel processing. Then we have latency. We can expect single digit milliseconds of latency, even faster with S3 Amazon Express one zone storage classes. It's good for real time applications as well as analytics. Then we have multi-part upload. It's very important. If you have, say, suppose very large files which is greater than 100 MB, so it's very recommended to use multi-part upload feature. So what are the benefits for using the features? You can upload parallelly uploading is provided, so which helps faster transfer as well as retry failed parts only. So these are the features where you can enable and use multi-part upload when your file size is 100 MB and greater than. So you must use this feature over there. So what it improves the speed as well as the reliability of the S3 bucket. Then we have data transfer acceleration. What it does, it uses S3 transfer acceleration. That is, it uses the AWS edge locations. Edge locations means the nearest location of your region. Say it uses it for faster uploads from distant regions. So if I suppose I'm located at Mumbai, so it will have a region closest to me or the edge location which is close to my distant regions. By using those, it will help me for transfer acceleration, that is for faster uploads from distant regions, right? So it works like whenever user is nearest edge, that nearest edge region is selected in the S3 bucket. Then we have parallelisms. Like parallelism, it's for keys for performance. Basically, we use multi-threading, upload and download multiple objects simultaneously. So parallelism is used over here. A big performance boost is achieved in data engineering pipelines and some of the ETL jobs. Then, as discussed in previous sessions as well, we have performance as per different storage classes. We have standard to express one zone. As per different storage classes, we have different performance. Fastest one, what we will get in express one zone, and the rest are the standard IA, Glacier, Deep Archive, depend upon the storage class and your requirement for the as per data. Then we have caching, advanced optimization. Here we use Amazon CloudFront. What are the benefits? Benefits we get is we have cache frequently accessed data. It reduces S3 load, then improve latency globally. So whenever a frequently used data is over there, so caching must be enabled, and it will save a lot of time for you and resources. Then we have byte range fetches. Basically it fetch only the part of an object, and it is very useful for large files and for video streaming. So whenever a part of instead of fetching all the object or a big object, it only fetches the part of an object wherever it's required, and selecting part by part, it helps in the byte range fetching. All right, so some of the common performance mistakes which people do is using single threaded uploads instead of using multi-threaded, not using multi-part for larger files as we recommended. When the file is over 100 MB, you should use multi-part feature. If you have too many small files, so that is an overhead for you. Ignoring caching. Caching should be used when the data is frequently accessed. Then we have some engineering pattern. It's parallel ingestion used in the S3 partition and prefixes with an EMR Spark, which parallel reads in the directory. So some of the best practices which you can follow: using multi-part uploads for large files, as we discussed, using parallel request, using prefix partitioning, using transport acceleration for global users, as well as for using CloudFront caching for the S3 storage classes. Right. A memory trick: parallel plus partition is equal to performance. So this you can expect in the S3 bucket. So that's all for today regarding S3 performance. If you like my video, stay tuned and subscribe my channel. Thank you.